The last thing that we're going to be looking at is optimization. Okay, so our goal is I can solve optimization measurement problems. Okay, 6.4. Okay, so exactly what does optimization mean? It means one of the two things that are behind here. It means that we want to maximize the area while minimizing the perimeter, and that's if we're working with two-dimensional objects. Or it could mean that we want to maximize volume while minimizing surface area. Okay, so essentially in this process, we're either attempting to choose the dimensions that give us the most desirable results. Now, the reason we do it is because in business, okay, think in business or even when you go shopping, packages are almost roughly the same shape, okay, the same size. And there's a reason for that, and it has to do with the amount. For instance, here, we want to have volume by using the least amount of surface area, because surface area in our packaging costs us money. Okay, so if we have a volume that we want, but we want to make sure that we minimize the amount of packaging. Same kind of thing here too. Um, and we're going to look at some questions dealing with both of those. So what we're doing is we're choosing the dimensions that will give us the best results for here. So in general, for two-dimensional shapes, the circle is the most optimal shape, okay? But think about it, it's not always the most practical. So I'm thinking here, maximizing area while minimizing perimeter. Okay, so I'm a farmer and I want to make a pen for my livestock outside. Well, so don't want to buy a whole lot of fencing, but I want to give as much area as possible. Not too many circle fences out there. There are a few, but not too many. In most cases, the best shape is going to be, in this case, a square. You're thinking a rectangle, a rectangle. Yes, a rectangle, but remember a square is a special rectangle. So the square gives us the best optimization. Okay, now for 3D shapes, the sphere is the most optimal shape. However, again, it's not the most practical. The next best shape is the cube. So think when you're going grocery shopping. I don't see too many sphere boxes out there. Well, they wouldn't be boxes, spheres out there holding cereal, for instance, because it wouldn't stay on the shape on the shelf. So they choose the cube will be the next one. Now, obviously, you don't see too many cubes either. And again, that's another reason. So when we're talking about packaging, we do other things as well too. Okay, so I think I have missed something here. And here it is. Okay, we try for us 2D shapes, we try to square everything up. Now, think about also when we're talking about a cube. Not everything is cubes either. So if I'm talking about cylinders, and I'm thinking of juice cans, for instance, if I wanted to minimize the amount of surface area, I would want to have the height and the diameter almost equal in height, and that will also give me the best. Okay, so if I actually looked at a drawing of this, for instance, and I'm getting my drawing up here. So for 3D shapes, obviously my cube is the best. Okay. Yes, I know, it doesn't look too much like a cube. And then the next thing that I would look at would be if I wanted to have a a cylinder, I would want the cylinder to kind of almost fit inside here. So if I had a cylinder in here, I'd want the cylinder's diameter and its height to be as close as possible to what a cube would be. Okay, and that would be the same thing too if I had a cone. I would want its height and its diameter to be the same as well. Okay, so we would want those dimensions to be as close as possible to being equal to each other.